This is Varlock, an open source tool for managing environment variables that makes it so that you never have to store plain text secrets on disk again, and works by resolving environment variables locally or through a password manager like 1Password, Bitwarden, AWS, and many more by using a type-safe schema, and then injects your secrets into your application at runtime, making your .m file safe for AI and even to commit publicly to GitHub. But how does this actually work? And what's the deal with this weird syntax? Hit subscribe and let's get into it. How many times have you started a new dev role, get access to the code, get it running locally, and it doesn't work, only to find out you're missing a .m file you need to get from another developer or some kind of encrypted storage, and you have to go through this process over and over again each time that .m file updates. This is the problem Varlock exists to solve, and also to fix the problem of prompt-injected AI agents fetching secrets they shouldn't have access to. Let's go through how it works. So here is a small project I've been working on that generates articles from Twitter videos using OpenAI's Whisper to transcribe the video and using Claude to write the article. But we're going to start with something simple and use Varlock to change the port number. So with Varlock already installed, we should have a .m schema file which is currently empty. This will be the source of truth for all of our environment variables and should be able to be committed to GitHub in a public repo. We'll start by adding a simple app-env environment variable, and we'll set it to the value of testing. And now I can create a new tab to run varlock load, which will validate our schema. Now we can see over here it's read our environment variable and has set it to sensitive. This is because all environment variables in Varlock are set to sensitive by default, but we can change that. In this file, I'm going to add our first decorator, which will be a root decorator because it will affect all the environment variables in the file, and will set default sensitive to false. Notice the syntax here has a hashtag in front of it, and usually root variables are separated with a divider. Now this whole file uses a domain-specific language called mspec, which is an open spec written by the Varlock team. So now if I validate my schema again, we can actually see the value of the environment variable because it's no longer set to sensitive. But we can do some other cool things inside our schema file, like giving our environment variable a type. So I'll give it a type of string, which means everything should still work. But if I were to change it to number, then we can see we get an error because it's expecting a string. I can also give it the required decorator and then remove this text, meaning if we check our file, we get an error because it's expecting a value. These are called item decorators, and you can find a full list of them in the Varlock documentation, as well as a full list of the available types. Let's now add another environment variable, and this time we're going to call it port with a value of 3002. I can give it a type of port, and what I'm also going to do up here is set this to sensitive and change this back to a string. Now it's picked up both of our environment variables and hidden this because it's sensitive. But now, how do we get these values into our application? Well, all we have to do is run varlock run, followed by the script we need to run our application. So if I cat the package.json file, we can see we need to run the vite command to run the front end. So now if I run varlock run, followed by the vite command, it should load the config, resolve it, and then inject it into our environment variables, which is exactly what it's done, because now the port is 3002, which works in our code because it first checks for the port environment variable currently being injected by Varlock. This script doesn't just have to be a JavaScript file because Varlock works for any project. So Python, Go, Rust, you name it, everything should still work as expected. And if you don't want to install it with npm, then there's also a Varlock CLI, which works just the same. This is all well and good for local environment variables, but now let's go through the process of fetching them from 1Password instead of using my shell local variables for things like this OpenAI and Anthropic API key. Now, I don't use 1Password personally. I've signed up for a trial just to make this video, but as you can see, I've created a new vault, which is very important. I'll explain why later. And inside this vault, we have two items. One is the OpenAI API key, and one is an Anthropic API key, which I don't mind showing because they're completely made up. So if I reveal this, this is not a real API key. Now, in order to get those values inside our Varlock schema, we first need to install the 1Password plugin. And note, plugins in Varlock can add their own root and item decorators. So you may see some new ones here that don't exist inside the documentation. For example, this init 1Password decorator. So after installing Varlock 1Password, we can load the plugin root decorator containing the plugin we just installed, and we can run the init 1Password decorator So all I need right now is the token, which I can load from here. Now, in order to get this token, you do have to connect it to a new vault, not your personal one, and you can find it in developer service account, then follow the steps to create a token. Now, since I'm going to delete my token and 1Password account after this video, I don't mind showing it. And I'm going to give this a type of 1Password service token, which is set to sensitive and is a type that comes from this plugin. You may also notice that this file doesn't have any syntax highlighting, and that's because the Varlock team have created a VS Code plugin that does support it, but right now there isn't one for NeoVim, which means I might create one in the future or just get Claude to do it. Now I'm going to create a new environment variable called OpenAI API key ID, and then in order to get that from 1Password, I have to run the 1Password function, followed by this protocol, and then I need to add the name of my vault, which is test, the name of the item, which is OpenAI, and then the field's name, which if we double check, we can see over here that it is credential. I can also set that to sensitive. And now if we run Varlock load, it takes a few seconds before getting my OpenAI API key from 1Password. And we can check it's working by even changing the value here to something like 1234. And if we run Varlock load again, it gets the correct values. And there we have it. Our env schema file should be good to commit. But I know what you're thinking. What about this 1Password token? Is that safe? Well, to be honest, if you were developing locally and you had 1Password, you may have the desktop app installed or you're using the CLI. In that case, you can use this configuration to unlock 1Password with your fingerprint instead of using a 1Password token. But Varlock also supports other plugins like one for AWS, GCP, and even Bitwarden, as well as many other integrations, including those for Vite, Next.js, and Cloudflare workers. There are also so many other features I didn't get round to going through, like generating TypeScript types from your schema, importing environment variables from other files, and even redacting sensitive outputs from logs and outgoing HTTP responses, which is a very nice touch. There's even an MCP server to help your coding agent set up an env schema for you automatically, and there's also a GitHub action to load and validate your environment variables in your CI/CD process. But as cool as Varlock is, there are a few issues with it. For example, you can't use it offline, so if you're coding at an airport, you'll have to use your hard-coded environment variables, but honestly, who's really coding without the internet? Also, speaking of internet, there is a bit of delay when it's fetching passwords from a different provider, so it will take a tiny bit longer to start up your scripts. There's also a lack of providers such as Dashlane and others, and I did experience a weird bug where if I used the same name in my schema file as the name of an environment variable for my local shell, it used that environment variable locally instead of the one from 1Password. But Varlock is actively being developed, and I'm sure lots of these things will be addressed in the future. Nevertheless, the product as is right now is still incredibly useful to me, and I think I'm going to be using it for all my side projects going forward, and maybe even replace my local shell files with Varlock schema files if there's a way to do that. I really hope there is, because I don't want any agents to scrape my information.